We're going to continue looking at experimental probability, which we started yesterday with our Starburst lab. Today, we're going to compare theoretical and experimental probabilities. So if you look at page 23 of your notes packet, you see that you have some pictures and a table comparing theoretical to experimental. So let's look at the first event. You see that we're rolling a die and we are looking for the probability of landing on a 2. Well, for this, we know that there is 1 2 on a die out of 6 total sides. So the probability of landing on a 2 is 1/6. But that is theoretically. That's what we think will happen. However, experimental probability is what actually does happen. So if you look at the experimental side, you see that we actually rolled 10 times and landed on a 2 4 of those times. So that means that experimentally, the probability of landing on a 2 was that they landed 4 times out of 10. And 4/10 would simplify to 2/5. So let's look at the comparison between this. The theoretical probability of a 2 was 1/6, and the experimental probability of a 2 was 2/5. When I look at this and I'm trying to find the difference, I can compare these by subtracting and saying one is greater than the other. Or I can just say that in this case, the experimental probability is greater than the theoretical probability because experimentally we had a greater chance of landing on a 2 than we did theoretically, since 2/5 is greater than 1/6. Now let's look at our spinner. We want to find the probability of a blue. Well, there is one blue section out of 4 sections, and since these are equal sections, then the probability of landing on blue is 1/4. Experimentally, we spin the spinner 10 times and land on blue 7 of those times. So experimentally, the probability of landing on blue is that we landed 7 times out of 10. So we're comparing 1/4 to 7/10. Well, I know that 7/10 is larger than 1/4, so in this case, the experimental probability is greater than the theoretical probability. For the next one, we're looking at a die again. So the probability of rolling a 5 on a die is that there is one side that has a 5 out of 6 total sides. Now, experimentally, we rolled 10 times and landed on 5 just one time. So the probability of landing on a 5 experimentally is 1/10. So this time we're comparing 1/6 to 1/10. Well, I know that 1/6 is larger, so in this case, the theoretical probability was greater than the experimental probability. Now let's look at our spinner. This is asking for the probability of pink or red. Well, when you look at your spinner, you see that you should have 8 total sections. And 1, 2, 3, 4 of those are either pink or red. So the probability of landing on pink or red is 4 out of 8, which would simplify to 1/2. Now, experimentally, we're going to spin 10 times, but we land on pink twice and we land on red 5 times. So in total, we landed on either a pink or a red 2 and 5 times or 7 times total. So the probability of pink or red is that we landed on those 7 times out of 10 total spins. So for this, we're comparing the theoretical probability of 1/2 to the experimental probability of 7/10. Well, I know 7/10 is larger, so in this case, my experimental probability was greater than my theoretical probability. Now I want you to go to page 24 and work on the problems on page 24. Let's check your answers. For the first problem on page 24, the probability of rolling a die and landing on an even number is 1/2. The experimental probability of that was 3/10. So we compared 1/2 to 3/10. Since 1/2 is greater, then my theoretical probability was greater than my experimental probability. For your spinner, The probability of landing on red was 1/4. Experimentally, you landed on red 7 times out of 10, so the experimental probability of landing on red was 7/10. So we're comparing 1/4 to 7/10. Since 7/10 is greater, then my experimental probability is greater than my theoretical probability. For our die, we're looking for the probability of a number not being a 3. Well, there are 5 numbers on a die that are not 3 out of 6 total numbers. So the theoretical probability of not landing on a 3 is 5/6. The experimental probability is that we did not land on a 3 8 times out of 10. So that was 8/10, which simplified to 4/5. So for this, we're comparing 5/6 to 8/10. In this case, since 8/10 or 4/5 is actually smaller than 5/6, our theoretical probability is greater than our experimental probability. And for your last one, you had to know which numbers are prime numbers. Prime numbers are numbers whose only factors are 1 and itself. So when we're looking at prime numbers, we want to find all of the numbers that are prime. If you think you know those, I want you to put those in the chat. Which numbers on the wheel are prime numbers? All right, for this, 2, 3, 5, and 7 are prime numbers. 1 is a number that is neither prime nor composite. So in this case, we have 4 numbers that are prime out of 8 total numbers, which is 1/2. Experimentally, we would spin 10 times, but don't land on prime 5 of those times. So this is 5/10, which is 1/2. So for this, our probability of not landing on prime theoretically was 1/2, and our probability of not landing on prime experimentally was also 1/2. So our theoretical probability is equal to our experimental probability in this case.